Today's lesson is Workplace and Apprentice 30.5 Transformations. We're going to start off with a little activating prior knowledge, scale factor. A scale factor is written in the form of scale and then colon original, and so the scale size to the original size, or it can be written as a fraction. And you'll often see it this way. It's easiest to calculate if it's in fraction form, scale over original. So the scale is always over the original size. When a figure is enlarged, the scale factor will be greater than 1. The new figure will have larger side lengths. When a figure is reduced, the scale factor will be less than 1, but it will have to be bigger than 0. We won't have a negative scale factor, and so the new figure will have smaller lengths. So when we look at the following scale factors, do they represent an enlargement or a reduction? A number of 2 will mean that your picture is getting bigger and it's an enlargement. 0.75 will be a reduction, it's less than 1. And 3.4 will be an enlargement. Okay, the original shape and the image created will be called similar figures. A poster has a length of 3 feet 2 inches and a width of 2 feet 4 inches. Kim plans to create a reproduction of the poster by enlarging each dimension by a scale factor of 2. What is the new dimension? So we're going to double each side. So 3 feet times 2 is now 6 feet. 2 inches times 2 is 4 inches. So the new side will have a length of 6 feet 4 inches, and when you double 2 feet for the width, it's going to be 4 feet 8 inches. If a house is 40 feet long, 35 feet wide, and the top of the roof is 27 feet above the ground, what will be the corresponding dimensions if you build a model that is 1 foot represents half an inch? So our scale is 1 foot to half an inch. So then we have a feet here, so we must put the feet on the top. And we cross multiply to find out what our new dimensions are. So 1/2 times 40 is 20 inches equals x. So we do that for every dimension we have. So we have 35 feet over x. So 17.5 inches equals x. And the third one is 1 foot to half an inch equals 27 feet to x. 13.5 inches equals x. The 2 octagonal windows are similar. Determine the scale factor used to create the larger window. So we take the scale. So this one is the original because it says we are creating the larger window. So this is the scale. So we take the scale, it's always on the top, over the original on the bottom. 24 over 13 is approximately 1.85. It's about 1.85. Now, what is the length of DF, this red line here, from here to here? Well, in the original, it's 34. So if we multiply it by the scale factor, notice the scale factor is bigger than 1. That's because we're getting a larger picture. We multiply it by the scale factor, and we get 62.9 centimeters will be the diagonal in that octagon. Review coordinate planes. We're going to do a couple of these points, and then I'll leave the rest of them for you to practice. When we are looking at coordinate plane, x is always going horizontally, y is always vertically. The positive x are over here. The positive y's are up here. The negative x is over here. And the negative y's go this direction. So in this case, you have positive positives. So positive x, positive y's. In this quadrant, which this one is quadrant 1. Quadrant 2, so they're actually labeled counterclockwise starting in the first quadrant. Quadrant 2, the x's are negative and the y's are positive. Quadrant 3, which is down in the left corner, bottom, the x's are negative and the y's are negative. And quadrant 4, the x's are positive and the y's are negative. All right, so the first number we're looking for is 1, 1, both positive. We always do the x's first, left to right, x over 1, up 1, put the dot there, and that's A. B is 4, 1, so we go right to 4 and up 1, that's B. Let's take a look at some negative ones. E, negative 2 and 3. So that means negative 2 is going to the left, but positive 3 goes up, and that's E. N, negative 2, negative 7. So we're going to go negative 2, and then y's are negative down here to negative 7, and this is N. Being able to plot coordinate points is very important in this unit, as we will be doing some moving of objects on a grid, and we'll have to be able to tell what the new coordinate points are. So I'm going to leave the rest of those for you to finish. And we also have to be able to read points. So if you're given a point, what are the coordinates? X's are always first. X, Y is always your coordinate points. X is first in the alphabet, so X is read first. So for example, A is over here, so you would read the x's first. It's going to be negative 9, and then you're going up 3, so positive 3. So A is negative 9 plus 3. Okay, E. E is here in the top right, quadrant 1. This one was in quadrant 2. 1, 2, 3, 4, 5, no, 4, positive, and up 7. And that was E. Let's try J. J is in quadrant 4. So it's positive 5 and negative 7. And N is in quadrant 3. And 1, 2, 3, 4, 5, 6. So negative 6 and negative 4. Get used to writing them down and also knowing what quadrant they're in, because that will help when we do the section on rotation. So we're going to stop there, and you are going to finish the practice 1 and 2 that are on the slides.